This is homework A, question 1. 3 loads in the figure below are connected in parallel across a 110 VRMS volt, 60 Hz sinusoidal voltage source as shown in the figure. The circuit is in steady state. Load 1 absorbs 250 true power and 500 reactive power. Load 2 absorbs 1850 at a negative 40-degree angle of complex power, and load 3 has a impedance of 3 minus imaginary 10 ohms. Find the expression for current X at time t. Assume that voltage S at time t is a cosine function with a phase of 0. So our voltage source equals 110 at angle 0, and in order to solve this question we need to convert each load into complex power. So load 1 equals 250 plus 500 imaginary, because complex power equals real power plus imaginary reactive power. Load 2 equals 1850 at negative 40-degree angle. But in order to use it to find the total complex power, we need to convert it, and we can convert it by plugging in 1850 times cosine at negative 40 plus imaginary sine at negative 40, which will give us 1396.21 minus imaginary 1189.16. In order to convert load 3 into complex power, we have to divide the impedance we need to divide the voltage by the impedance. So complex power of load 3 equals the voltage squared over impedance, 3 minus imaginary 10, which gives us 333 minus 1110.1. The total complex power equals 250 plus imaginary 500 plus 1396.21 minus imaginary 1189.16 plus 333 minus imaginary 1110.1, which gives us a total of 1979.21 minus imaginary 1799.26. We then divide total complex power by the voltage in order to get RMS current. This gives us 17.99 minus imaginary 16.36. We then have to convert this into its conjugate in order to find the current for Ix at time t. Then we multiply 17.99 plus imaginary 16.36 by square root of 2, which gives us 25.44 plus imaginary 23.12. Then we convert this into its polar form, and that gives us 34.38 at an angle of 42.27. So our final answer is Ix at time t equals 34.38 cos to find the rads over S. We multiply the frequency times 2 pi. So the frequency is 60 hertz. So 60 times 2 pi equals 377 times t plus our angle 42.27 degrees, and the unit is amps.